For over a century, our world has been powered primarily by carbon fuels. In recent years, concern about global warming and the harmful effects of fuel emissions has created new demand for cleaner and sustainable energy sources like wind. In many areas around the globe, the energy market is also being driven by a dual new dynamic: deregulation and privatization. As more and more consumers choose who produces their power, the market for renewable resources is forecast to expand at an even greater pace. Wind power generation in Ireland has gathered pace in recent years, and Airtricity's commitment to development of wind power has been borne through the development of several wind farms. One such farm, Tournafulla, is located close to Templeglanton in County Limerick. Airtricity began construction of Tournafulla in 2 phases. Phase 1 consisted of 5 GE 1.5S turbines and started in April 2006. Phase 2 commenced in May 2007. This is the story of Tournafulla.
Tournafulla would have been one of the projects that I would have come across through Joe O'Mahony and Finbar Timon initially. I think both Joe and Finbar would have worked as consultants really to Airtricity at the time. And really working with families like the Curtins in the area there, we initially got involved in developing a wind farm project down there.
To build Tournafulla was part of our first multi-site, multi-unit procurement strategy with a supplier. So our procurement team decided that in order to gain efficiencies within costs and timelines, that they would procure a number of turbines for a number of sites simultaneously. And Tournafulla was one of the beneficiaries of that site. The other unique aspect was phase 2, in that we built 38 kilometres of underground KV cable. We built this in partnership with another wind farm developer known as Southwest Services, and their wind farm is not far from this, and it's known as SWS Maguire. So that was a unique aspect to the project in showing cooperation between the developers, and it's worked out very successfully.
Tournafulla required the construction of 18 turbine bases, roadways and over 38 kilometres of underground cable. Ground surveys also showed that some of the turbine bases had to be pile-driven to allow construction in soft ground. The responsibility for the overall groundwork for Tournafulla was rewarded to SIAC Construction.
In total, there was 18 turbine bases constructed between phases 1 and 2, and the whole project was completed in an approximate 2-year period. Between phase 1 and 2, there would have been a slight downtime between both phases. 18 turbines, 6 kilometres of site road had to be constructed in that period. Obviously, the work we're doing too was very weather dependent, and the weather, unfortunately, in summer 2007 wasn't very favourable, but we managed that to the best of our ability. Well, the ground conditions were generally good. As you can see, it's primarily agricultural land with some shallow peat in certain locations, and there was 2 locations where the presence of glacial silt and clay led us to having to install some load-bearing piles under two bases. The construction of the individual bases themselves was a 3-stage process. The excavation, obviously, of the base and the adjacent crane harsh landing. The primary base was then constructed. Each base contained approximately 250 cubic metres of concrete and 16 tonne of steel. Once the initial primary base was poured and cured, we then had to build what's known as a pedestal to receive the foundation mounting part, which is what's known as a can on which the GE turbine sits. The pedestals were then poured using 60 cubic metres of concrete and approximately 6 tonne of steel.
With the roadways and turbine bases complete, the turbines could now be delivered to the site. Turbines arrived at the nearby port of Foynes and were unloaded and stored there. Turbine transport is done in the early hours of the morning, as the components of the turbine are oversized and getting stuck in traffic is not an option. The turbine delivery was the responsibility of GE and transport company KVN.
Within the transport of turbines, a route survey must be carried out from the port to the site. And to carry out this route survey, because the length of the trailers for the blades in particular are 60 metres approximately. So as you can imagine, getting around some tight bends on Irish country roads can be quite difficult. So in certain instances, we would have had to modify certain corners on roads to allow the turbines to access the site. In this project, we had to modify the road from the N21 to site. We have had to widen it, and it had to be resurfaced, and we had to improve a number of corners.
For this particular project, Tournafulla, we transported the components from the various manufacturers around Europe into the port of Foynes by ship. We unloaded the components in Foynes with the use of the harbour cranes and everything that is, all the requirements there. And we then loaded them onto the transportation vehicles and transported them the short distance here to the site of Tournafulla.
Turbines are delivered to site when required. The erection of turbines requires the use of 2 cranes, a 500 tonne and a 100 tonne. Turbine erection can only be done when the wind speed is below 9 metres per second.
The process for the erection of this turbine is, for the 1.5 megawatt turbine, which we have here, is that we build it on a just-in-time delivery basis. That means that we deliver the items from the port, and if the weather allows, we erect the components straight from the vehicles, the transportation vehicles, onto the foundation. The first component that arrives on site is an item we call the PPM vehicle. It's a 3-tier steel construction, which is then assembled and bolted together and then lifted onto the foundation. On this PPM module, there are the electrical cabinets and the equipment for the actual working, and the computers for information to be sent back to Airtricity and also to our facility in Germany. The second, what then happens is there is a second, the second vehicle is the base tower section. This is erected between 2 cranes. The type of cranes that we have here for this particular site was a 500-ton telescopic crane and a 100-ton tailing crane. These components are then lifted by the 2 cranes off the vehicle and what we call top and tail until the tower section is actually in a vertical position, where the tailing crane is then disconnected, and the main crane then lifts the base tower section and places a base tower section over the top of the PPM. And our guys then bolt it to the foundation adapter piece. This is also carried out, the same system is also carried out for the second and the third tower section.
With the tower complete, the nacelle is raised into position. At 52 tons, the nacelle is the powerhouse of the turbine. When complete, it will operate in winds from 13 meters per second, generating 1,500 kilowatts of green power. The nacelle is hoisted over the tower and lowered into place. When all the holes line up, the nacelle is then bolted in place. Not until all the bolts are firmly in place will the crane release. With the nacelle in place now, the turbine erectors have the task of raising the blades. The blades are bolted onto the hub on the ground. Then the entire assembly is ready to go. The 500-ton crane takes the strain, while the 100-tonner is used to spin the blades into the upright position for the lift. Lifting 33 tons of blades requires great skill from the crane operator and turbine erectors. The crane operator is to guide in the blades and hub 65 metres above the ground, blind, under the guidance of the turbine erectors. Slow and steady, the blade assembly is lifted into position. The ground crew use guide ropes to keep the blade assembly stable as the lifting takes place. The blades are naturally designed to spin in the wind, so lifting can only take place when there is little or no breeze.
The erection time for this size and this type of turbine, which we have erected here in Tournafulla, is basically on a 2-day basis. This obviously depends on the weather. We had various problems, especially with phase 2 of Tournafulla. With the 30 machines, we had a lot of downtime due to wind.
As the hub is guided into position, a steady hand is required. One jarring motion now could easily damage the threaded bolts. This is precision lifting. The hub is now bolted into place and another turbine on the Tournafulla site is complete.
The first power backfeed, or energisation as it's sometimes known as, on phase 1 occurred in February 2007 with final operation and reliability runs leading to takeover occurring in April 2007. On phase 2, power on occurred in March 2008 with takeover happening in May 2008. So as of May 2008, the wind farm is fully operational. The impact the project has on the environment is that the power from the wind farm can power 14,500 standard homes. It will displace 66,000 tonnes of CO2 on an annual basis and is the equivalent of 12,500 cars on the road.
Tournafulla Wind Farm now takes its place amongst the many farms that Airtricity now operates in Ireland. Tournafulla would not have been possible without the foresight and partnership of the landowners whose land the farm is built on. This partnership between Airtricity and the landowners goes far beyond the provision of a site.
Well, one of the key points about Airtricity's involvement in the local community is that landowners' opinions are important to us, and that they own the land. We were borrowing the land to put our turbines in. So their input into how road design locations should be, turbine locations, is quite important. Landowners need to farm the land when we're finished. And there are certain fields that might produce better than others, and they would request that you place turbines in certain locations. And all of that is brought into the design process. Additionally, it's important that during construction that we minimise the interruption to the farms. So we have a constant communication with the landowners, finding out have they any difficulties, resolving those difficulties to the best of our ability.
Well, certainly we want to be a good long-term neighbour for the community in Tournafulla, and we would certainly have a policy of allocating a certain amount of the revenue that comes from the wind farm into local projects for community benefit, and that would certainly be the case here. I think we've already been involved in 1 or 2 projects to date, and we hopefully that will continue over the future as well.
The benefits of having turbines on my land, the obvious one I suppose is there's a financial benefit. The land is, the plot of ground that the turbine is built on is rented to Airtricity, and they pay an annual rental for the ground. As you can see, my cattle here behind me are happy to graze away directly under the turbine, and it has no effect on them whatsoever. They don't even pay any attention to it.
Well, I'm with the same company the last 6 years, and I've been driving to Limerick, which is a 70-mile round trip in the day, so to be only 5 minutes up the road was a huge advantage. And safer with the dangers on the roads, I was quite happy to be here. And plus, working locally, and I love the land anyway, so it was really into my barrow now, to be quite honest. So it was one of the nicest jobs I ever worked on. So it was.
Airtricity will benefit the community because local organisations can apply for funding that will come via Airtricity, and there will be ways and means of applying for those. This Halla Gaelic, that's the Heritage Resource Centre here at my back, was funded by Airtricity, and back in 1999 and 2000, when it was difficult to get money. We got £20,000, which was a huge benefit to us in the erection of this community centre.
The turbine has increased my farm income considerably. It gives me more options in farming, especially the way farming is going. It also, it's about having the same as an extra 20 cows without the workload or the stress of it. Well, the improvements they've improved my roadways considerably for moving cattle and for bringing in bigger machineries to cut my silage, like set propellers and bigger tractors and trailers, which cut down the time that it takes to bring it in.
So in terms of the future for wind power, very, very positive. I mean, oil is up at record highs. It means that we have a huge drive towards alternative forms of energy being used to generate electricity, particularly moving away from oil and gas. And certainly wind now is a proven technology. So I think it's very positive, both for Ireland as a whole and for the Limerick area and for the Temple-Glantine area in particular. We're going to see this development taking place there. And that's going to bring funds in the long term into the local community. So I think it's very positive.